Welcome to the screencast where we're going to teach you how to use a Monte Carlo simulation to simulate Gaussian data. So the idea is that we have these data that we were looking at before with the grade distribution, and we figured out what the mean and standard deviation of those were. Now we're going to say that, okay, we have a Gaussian distribution with that mean and standard deviation, and we're going to sample that Gaussian distribution. So we're basically going to pick, just kind of randomly out of that distribution, pick data points. And if you pick a whole bunch of data points, you should see that the data points you're picking end up being a Gaussian distribution. So let's take a look at how that works. What we're going to do, let's delete those. What we're going to do is we're going to use a Gaussian with the same mean that we had before, because we're basically going to try to reproduce the grade distribution that we had before. So I'm going to take the average, so the average is the same. I'm going to use equals, and then I'm going to grab the same standard deviation as before. So we have 64.5 and 10.65 for our mean and standard deviation. And what we're going to do is we're going to now create basically random data based on that distribution. So this is the function we're going to use, and the very first thing I want to do is I want to look at this rand function. So actually let's go to a different tab here quickly, and the way that rand works is it gives you a random number between 0 and 1. So rand with the little parentheses and nothing in there gives you a number between 0 and 1. If I just do a whole bunch of random numbers, you see that I get a whole bunch of values. There's a interesting and odd feature is that every time you kind of change something in a spreadsheet with these, you might have all the random numbers get recalculated. It kind of depends how you do it. But see, I just deleted something and now all the values changed. So you want to make sure that you take enough random numbers that the random number any given random number changing isn't going to really change your overall findings. So we have this function called norm_inv. So this is basically an inverse normal function. It is taking the cumulative probability distribution of a Gaussian, and it's defining the Gaussian as having a certain mean, which is the second value, and a certain standard deviation, which is the third value. So that's our input mean and our input standard deviation. And then you input a number between 0 and 1. In this case, we're using a random number, and this is going to give us a random Gaussian number out. And the number will be sampled from the distribution that has our input mean of 64.5 and our input standard deviation of 10.65. So let's delete this little thing right here, get it out of the way. And what I'm going to do is I'm going to take this and I'm going to actually sample it 200 times. So I'm going to take this and go all the way down to cell 207 and fill this down, Control D. And now you can see I have a whole bunch of sampled data that look like they're centered around 65. And I've already taken the liberty of histogramming this, and you can see that my histogram looks like it's got the similar type of distribution to what we had from the original data that we used for the in-class demo and the other screencasts. And let's take an even closer look. Let's actually calculate the mean and standard deviation of these data that we just produced. So I'm going to calculate the mean by is equal to the average, and do this. And okay, the average looks basically the same. And we're going to calculate the standard deviation. So standard deviation, and for all these simulated data. And we now have a mean and standard deviation that look very similar to the original ones. So the ones that we used to create the data, if we actually create enough simulated data, then you will get the same mean essentially the same mean and standard deviation back out.